Hi, welcome to the course Data Structures and Algorithms. Today, in Lecture 1, we are going to discuss the Introduction to Data Structures. In this, we will be discussing the following topics: the basic terminologies used in data structures, and the definition of data structures and its operations. Rest we will discuss in the next class. To introduce data structure is a way of collecting and organizing data in such a way that we can perform operations on this data in an effective way. In other words, we can define data structures as they are like a storage in which we can use our memory effectively in handling the data that are required for future purpose. That is, the way we arrange the data in a computer memory so that it can be accessed effectively and updated efficiently then and there we need. In other words, we can say it is a structure. It is the way we store the data in the memory. Why we need to store data? Because in future we need to return it from the memory, to retrieve it from the memory so that we can process at later stage. So how you can define data? Data is nothing but a value, or you can say raw facts. If you say number 5, 5 is the data. When you process that 5 with some entity like boxes, so you can say 5 boxes. When you simply say 5, it doesn't convey any meaning to us. It's just a number. And if you say box, yes, it's just an object. So when you put together 5 and boxes, then you can understand, yes, it is some information. There exist some 5 boxes. What they carry some materials. Then you can define that adding more facts and figures, adding more data to the existing data, or you can say processing of data, then it will give you then information. So all the communications are happening based on information. So the basic facts of an information is a data, and what type of data it is, how it is stored in the memory, and how it is retrieved. I'll tell you, people have different behaviors to different scenarios. So for example, if somebody hits you, you behave with little angry. Somebody praises you, you behave with little joy. To every how you are being handled, you are behaving the same way. Data are being handled and behaved, made to behave something. So this course data structure is going to give us a clarification on how can we store data and how we can operate them. So to define it, it is a way of collecting and organizing data in such a way that we can perform operations on these data in an efficient way, effective way. The basic terminologies, before we get into that, how we can define data value or set of values. Data item refers to single unit of value. So there are group of data. So data item that can be subdivided into sub item like, okay, you take your name. Your name has 3 different parts like first name, middle name, last name. Like that, you can perceive any data as a collection of some data item. If you tell like a computer, then it is a combination of, it has 3 different parts like monitor, keyboard, and the CPU. Likewise, every group data item will have multiple sub data items. Let's come to the next terminology, elementary data item. Like data item that cannot be subdivided into sub item, then they can be called as elementary data item. So here the data example for elementary data item is PAN card number. Like PAN card number, you cannot divide it bank passbook number, you cannot divide it. They are the building blocks of some information. Okay, let's go back to that previous example. The name can be divided into perceived as three different sub items like first name, middle name, last name. Can you divide this first name? No, you cannot. So in that way, first name can be called as an elementary data item. Hope you understand, right? Okay. So collection of data are frequently organized in a hierarchy of fields, records, and files. Like if I ask you to fill up an application form, then you will be writing your name in first column, then your date of birth in second column, your father's name in third, and likewise you will be having some five or six headings about your personal information. So they can be collectively called as a record. They can be collectively called as a record. Say Ramsamy is filling his form. His name is H. Ramsamy. Then his date of birth, he'll be entering his date of birth, date, month, year. Then he'll be entering his father name. Then he'll be entering his mother name. Then he'll be entering his residential city or town or anywhere, anything. So these five data items come collectively together and called as a record of Ramasamy. So what are they individually called? They are individually called as fields. So name is a field, date of birth is a field, father name is a field, then the mother name is a field, then address or location is a field. So collection of data items, how they come under a group item. Here collection of fields comes under records. Okay, if I have a file, box file collecting all the students profile, personal profile like this, then that entire box is known as a file. So file is nothing but collection of records. So this is a hierarchy we must understand before getting to data structures further. So understand the hierarchy. Letters put together, you can get a fields. Fields put together, you get record. Records put together, you get files. So what is entity here? Entity is like individual field. You can call it as entity. Similar attributes like example, all employees of an organization form an entity set. So here a student is an entity. His details are being collected and processed, and that processed data can be called as information. So data with given attribute is known as information. So field is a single elementary unit of information representing an attribute of an entity. So if you say Ramsamy, Ramsamy is an entity. So for him we maintain different elementary data, or in other words different fields. Then the fields collectively represent Ramasamy. So you can call that as a record event. Record is a collection of fields of a given entity. So Ramsam is a given entity. So if you maintain a collection, a group of fields for Ramsami, then it is called as record. Finally comes to files. File is the collection of records of the entity of a given entity set. Then now coming back to that box file is having some 30 to 40 students records. So each student record can be called as an entity. Then collectively the class record can be called as entity set. The example given here, student A and student B and their age, sex, roll number, branch they are doing. So this entire table can be called as an entity set, and this every rows can also be called as entity or record. Then every field or single elementary data. So all collectively gives you a data structure. That data structure is known as table. So records can be of two major categories. One is fixed length record, another one is variable length record. So fixed length record, all records contain the same data item with the same amount of space assigned to each data item. So there won't be any difference between the length of the fields in that record. But whereas variable length record, the fields, file records may contain different length of fields, right? Okay, we'll come here. I'll give you an example here, like Ramaswamy, Ramasamy. So 8 characters required to store this data. Name Ramaswamy. Likewise, if you want to store Ravi, then RAV, only 4 is required. Half the space is going to be wasted if you follow fixed length record system. Whereas if you follow variable length record, then uh, according to the number of characters entered, the length of the record gets adjusted. Length of the record gets adjusted. So that kind of file or data structure we can call them as variable length records. So if you want to study data structures, then you have three major things must be followed. The first thing is logical or mathematical description of the structure. Logical or mathematical description of the structure. This talks about how many memory locations or how many words or how many bytes are being used. So that particular aspect we have to talk about data structure. Then implementation of the structure on a computer. So how it is being implemented, like in physically, how it is going to get stored in your hard disk, that is your storage, how they are going to be stored, in which locations they are going to be stored, how contiguous they are, I mean, like how continuous they are. Are they being stored in for sequence of memory locations one after another, or they are going to be stored here and there? Like if you go with sequence, then you can call them as a stack kind of storage. And if you store the data in memory scattered here and there in your memory locations, then you can call them as heap kind of storage. So that implementation we have to discuss. Then quantitative analysis of the structure, which includes determining the amount of memory needed to store the structure and the time required to process the structure. So from the mathematical perspective, here we are going to add one more, that is the time required to store the data structure or process the data. Here process is nothing but storing and retrieving. Next, we are going to talk about the classifications of data structures. So classifications, like data structures can be classified into two major parts. Like is one is primitive data structure, that is basic. The another one is non-primitive data structures. These non-primitive data structures uh, are constructed or established or created with the help of the primitive data structures. Okay, I'll give you another example. A brick wall. You just assume a brick wall. That's nothing but array of bricks. So what is brick? Brick is the basic building block of that wall. Likewise, primitive data structures are the basic building blocks for the data structures. Primitive data structures are the basic building block of any data structure, any non-primitive data structure. So primitive data structures are like integers, float, character, and pointer values. The integer value, if you write 5, then it is a primitive data structure. If you write 5.10, 5.10, then it is like float. Then if you simply say A, B, C characters, then they are primitive data structures. So all these comes under primitive data structures. All these primitive data structures are collected together to form non-primitive data structures. The most familiar one, which you have experienced a lot in your previous programming classes, arrays. Arrays, what do you mean by array? How can you define array? Array is a collection of homogeneous data items in a single name. If you say, okay, we'll take array declaration in C programming. You declare like int of A. A stands for number of elements that we are going to have it in that integer array. Int A, open square bracket and close square bracket. If that is the case, A is the name of the array. The number which is displayed within the two square brackets is going to be the size of the array. Here, what's happening? A is an array and it's going to collect a few count of integer data. So now look at the relationship between integer and that is primitive data structure and non-primitive data structure. Likewise, We are here introducing two new non-primitive data structures which you may not have experienced in your past programming languages. That one is list. List, yes, again divided into two major types, linear list and non-linear list. List means what? The moment we say list, what comes to your mind? List of items. Mom usually write list of grocery items to be purchased in the beginning of the month. So 1, 2, 3, 4, 5, 6 continuously. So there, linear list, non-linear list. Linear list means it has restrictions, lot of restrictions like how it can be stored and length it can be stored, like stack and queue comes under linear list. In non-linear list, you have graphs and trees, and one more thing is missing. There is that is one more thing that missing in linear list. There is a linked list. What is stack? What is queue? What is linked list? What is graph? What is trees? We'll have basic understanding. Then we'll have detailed discussion in the concern lecture. Stacks are uh, piling of data one above the other. It is a kind of data structure. So here we can understand what data structure all about. See, if you follow stack or queue or linked list or graph or tree or array, everything is going to get stored in your common storage, that is your hard disk. Then in what way these people differ, sir? Of course, the way they store and retrieve the data, the procedure that is being followed, the steps that is being followed, in other words, the approach that is being followed by these structures differentiate them from one from each other. Apart from that, they do have their own specific applications. So, the approach they are following, the applications that they are going to support differentiates these data structures, but otherwise all are same, all are going to get stored in your hard disk only. Okay, next we'll discuss the basic operations that we do with the data structures. If you take any data structure, you have a kind of operations. First one is traversing. Traversing means like okay, from this point to from source to destination you need to travel, then you will be going through all the individual stops and understand like what it is. So likewise, traversing means going and visiting all the elements at least once in that data structure. Searching, yes, you have to search for some element that you have stored. Then insertion, yes, insertion like adding new element into that particular data structure. Deletion, removing the element from the data structure. Sorting, arranging the elements in the data structure in a particular order like ascending or descending or something. Then merging, like you have two different set of data which can be merged together into a single data structure. Two different data structures merging together into a single data structure. These are the basic operations. Here is the basic definition of those operations. So traversing is like accessing each record exactly once, at least once, so that certain items in the record may be processed. Searching, finding the location of a particular record with a given key value. Here, key value could be the positional value or the data which you want to search that itself, or finding the location of all the record which satisfy one or more conditions. So here condition is like okay, if I have a list of ages in, okay, if I have an array of age of the students in the class, the subscript of the array says the serial number or roll number of the student, and the value stored in that subscript says the age of the student. If I want to identify which roll number are having even number of ages, then this is a condition. This is one condition. Okay, and I will be adding multiple conditions like okay, I want to extract the age list of roll number of students having age even but above 20 below 24. Yes, of course you can have it. These are the conditions for searching. Next comes inserting, adding a new record or element into the data structure, deleting, removing a record or data from the data structure, sorting like managing the data or record in some logical order, as I said, like ascending or descending order. Finally, merging, like combining the record into two different sorted lists into a single sorted file. So these are basic operations normally we do with all the data structures. Let's revise like what we discussed for past 20 minutes. Can you fill up the blanks like data structure is a way of dash and dash data in such a way that we can perform tasks on these data in an effective way. Come on, try it out. Yes, exactly. Data structure is a way of collecting and very good organizing data in such a way that we can perform what? Good operations on these data in an effective way. Okay, fine. Next, data means correct values or set of values. Good. In other words, you can define data is a collection of exactly raw facts. Data is a collection of raw facts. Come, let's do some match the following game. Like, okay, information, record, file, data, data item, group item, elementary item, all comes under the basic elements of data structures. The right hand side, applications of data structures. Now, to which application you are going to match information? Very good. It is a processed data. Record means yes, collection of field values. File, collection of records. Data, it's a value, simply value. Data item, an example for data item. Yes, single unit of values or data item. Group item, family. Of course, family is a group item. Family can be divided into father, mother, son, daughter, like that. Very good. Address, yes, of course. First, door number, street name, address 1, 2. Normally, in address, we'll have 4 or 5 lines. So, it's a collection of data item under a group item. Very good. Next comes elementary data item. Yeah, mobile number is elementary. You cannot divide mobile numbers. Like if you say 944305606, you cannot divide 94430 separate and 56066. Fine. Then comes elementary data item. Of course, pin code. Pin code you cannot divide it. Pin code cannot be divided. 642.0.8 is our pin code. Can you divide it? 642. What is the meaning? It is giving nothing. Very good. So hope you have had basic understanding on data structures. The basic terminology is going to be used in data structure and classification of data structure, and finally the basic operations that we are going to perform with the data structure. Thank you for this lecture, and we'll discuss remaining in the next lectures. Thank you.